Krishna will explain. Push pop and say, okay. Yeah. Right. Now can you explain quickly? Babega.
And this value goes here. That is and other case number pop. So given 0 D0. 0 D0 is PSW. So when you do pop, now the stack pointer was at 18. It will retrieve the value, then reduce the value of stack pointer. So PSW will become 18. And then stack pointer comes back to 7.
No. Only push and pop. Concept is clear. What when push instruction is executed, what happens when pop instruction is executed. This is clear. Wherever this concept, the instructions are used, you should be able to analyze the program like that. Is it clear now?
Yeah, it's the mystery of PSW or
Yes. Akshay, is it clear? Any other question related to push and pop? This why we have taken 7 directly. Default value of SP is 7. All the rest of the register except port register is 0. Port register is FF. For all the ports. 4 ports you have. Port 0, port 1, port 2, port 3, they will become FF when you reset. In all other registers will be 0, port 0 and SP as a different value. Other than that, everything is 0. Is it clear? Right. Done? Is it clear? Right. Any other doubt? Quickly. If you have a doubt, we'll discuss. Otherwise, we'll discuss the arithmetic instructions. Arithmetic instruction. You know. Push A, it will not understand. That we have discussed. Push at A? No. What do you mean by at A? At will work with only R0, R1 and DPTR and PC. No. At R0 will not understand. See, why it will not understand? Because whenever I say at, it is indirect addressing mode. Push will work only in the direct addressing mode. Push or pop, they will work only in the direct addressing mode. Did we mention this at the last? Mentioned it, yeah. We have mentioned it at the end that like push and pop will work in the direct addressing mode. Right? Clear? They will not understand your register number, register name, A register, B register, R0, R1, they will not understand. At R0, they will not understand. It will work only in the direct addressing mode. You can also use push 000. What is this? Instead of writing R0, you should use 00. R2 and R3. How do we do exchange? How do we do exchange of content of R2 and R3? Push R2 and push R3 and retrieve R3 and R2. In the same way you should retrieve. Let's see, R2 is 15 and R3 is 99. Okay. If I do push, what is R2 value? 02H, then content of 02 will go to here, 15. Then another push if I do, push what R3 value 03H, if I do, then 9 will hold 99. You're understanding this? Are you understanding this? Stack pointer default value is 7. Once I say push, what it does first, it will increment the stack pointer, then stores the value. It increments the stack pointer value, then stores the value. What value? Whatever the value you have mentioned here, and it is direct addressing mode. It is only direct addressing mode. So 2 is a address in the RAM. That address is nothing but R2. R2 has 15. 15 will go to here. Right? Similarly, if I do with 3, 9 will go 9. Now what I do? Pop 02H. Then what it happens? 99 will come to 02. And then it decrements to 8. While pushing the value, it is increment, push a value. When it is retrieving, retrieve and decrement. It has to be reverse exactly. Is it clear? 03. Now the content of both have been exchanged. That is why it is called as last in, first out. Last in, first out. Last value what you have added here will be taken first out. Will come out first. Is it clear? Right. This is a simple program that you should write for exchanging the content of R2 and R3 register using push and pop. Right. Done. Right. Shall we go to the next one? That is our arithmetic instruction. What we have discussed in the arithmetic instruction. Did we say it like there are? Okay. I was just counting the number of instructions available. We know that there are 255 opcodes available. 255 opcodes. And 44 instructions are there. Totally in 8051, 44 instructions are there. What is the difference between opcode and instruction? The instruction here is move. Right? The opcode is for move a comma hash 20, there is a different opcode. Move a comma R0 has a different opcode. But instruction is same. It does move operation. So what you have to concentrate is only on these 44 instructions. In that, how many we have covered in the data transfer? Move C, move X. Naku 7 aitu swap andu. Swap. Including swap, 8 instruction we have covered in this. Under 44, 8 we have covered. One more we have covered. What is that? No. Nop. No operation. Nothing it will do. So 9 instructions we have covered. And then we have said the arithmetic instructions. How many instructions are there in arithmetic? 8. So 9 plus 8. 17. 17 instructions is what we know till now.
and we know something DJ and Z, S jump and all that we know, we'll discuss that again. Right now, according to the operations, specified the instructions. In that data transfer, there are 8 instructions. In the arithmetic, there are 8 instructions. One instruction is NOP. No operation. NOP. NOP is no operation. Nothing it will do. Simply it will waste the time. Okay? Right. Next one, arithmetic, what we have said. We have just mentioned this one. In that, okay, at the same time, I also want to know how many programs we have discussed, like largest, smallest, ascending, descending, search an element, move internal to external, all that 5 programs, right? 5 plus 5, 10 programs we have discussed. I want you to write those 10 programs somewhere. If not in here, somewhere you should write it. Understand them. Okay, in that, some programs are there in the lab. You will do there compulsory, but like apart from that, if we miss anything, you should practice it. Only and only for your confidence. Your confidence will rise. Okay? Right. Then, now what we do is, we have one small program in the arithmetic. Please write down that program. Please write down that program. What is the program? Write a program. Write an ASM program. Write an ASM program to find the sum of values. To find the sum of values. Write an ASM program to find the sum of values from 40H to 44H. 40H to 44H. The result should be stored in R7. In bracket you write higher byte. R7 higher byte. In bracket you write higher byte. And R6 lower byte. And R6 lower byte. Done? What is the program? Have you done the, guys listen now. Have you done the addition of all the numbers in the Excel sheet? You give all the numbers, say sum of from here to here, it will give you the answer. How it will give you the answer? It has to add every element and then like it has to give you the total sum. The same program is this. It's the same program. What we are saying, there is a memory location from 40 to 40H. 40 to 44H. In this some values are there. You add these values, get the sum, store if it is 16 bits. Normally when we add so many numbers, the prediction is that like it might go to 16 bytes. So if you get a 16 bytes, store R7, higher value, R6, lower value, higher byte, lower byte. First thing what you should do? First thing what you should do? Before writing a program, you should put all FFFF and add them first. And understand what is the largest possible sum. You will know like how to write a program. First you take a calculator and add FF plus FF 5 times 5 locations, right? Imagining like all this memory locations have the largest number. All FF. Quick, what is the answer? Huh? 4FB. 4FB, that's all. Right? So higher byte here is 04, the lower byte here is FB. Is it clear? It has its own trick. It has its own trick. It is not easy. Try this. Janavi, how do you do this? How do you start? Let us say, how do you start this program, writing this program? What do you know? You know that it starts from 40. Put this in R0. What else you know? You know there are 5 bytes. Put this in R3. What else you know? That's all the information you have. Whatever the content it might be, you should add it now. Right? This is in R0, this is in R3. The result is here. Quickly, try ಮಾಡಿ. We have to discuss one very important instruction in this. Oh, okay, listen. Before that, you have written arithmetic instruction on top, right? In bracket, you write 8 instructions. 8 instructions. And before you have written the data transfer, right? In that you write 8 instructions. In bracket there 8, here 8. Data transfer 8 instruction, arithmetic 8 instructions. 16 plus 1, NOP instruction 17. 17 instructions we have studied till now. Try independently. Don't look at others' notebook. If you don't know, then like give yourself some time and then you look at around. Janavi, ನಿನಗೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು. ನೀನು ಸ್ವಂತ ನಿನ್ನ ತಲೆಗೆ ಹಾಕಿ ಟ್ರೈ ಮಾಡು. ಒಂದು 5 ನಿಮಿಷ ಕೊಡು ನಿನ್ನ ತಲೆಗೆ. ಆಮೇಲೆ ಬೇರೆಯವ್ರ ತಲೆ ಏನು ಮಾಡ್ತಾ ಇದೆ ಯೋಚನೆ ಮಾಡಿ. ಅದು ಆಡ್ ಸಿ ಮಾಡಬೇಕು. What is that? I don't know. Sir, 2 ನಂಬರ್ ಆಡ್ ಮಾಡಿದ್ರೆ ಒಂದೇ ಕ್ಯಾರಿ ಬರ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ. ಕ್ಯಾರಿ ಒಂದೇ ಬರ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ. ಇಟ್ ಕ್ಯಾನ್ ಬಿ 0 or 1. ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಆಡ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಆಡ್ ಸಿ ಮಾಡಿದ್ರೆ ಮತ್ತೆ ಕ್ಯಾರಿ ಬರ್ಲಿಕ್ಕೆ ಒಂದೇ ಸಾಧ್ಯ. 4 is not a carry here. 4 is a number that we have to. Akshay Hegde, ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. What you have to do? That means you should sit in first bench. No, if you sit in first bench, you will get an answer by yourself. If you sit at the here, you will not understand. Huh? You try ಮಾಡಿ ನೋಡು ನೀನು. ಫಸ್ಟ್ ಬೆಂಚ್ ಕುಂತು ನೋಡು ನಿನಗೆ. ನೀನೇ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಆದ್ಮೇಲೆ ಹೇಳು ನನಗೆ. What that got to do is you have to tell me back. It has worked or not worked ಅಂತ. For everybody whom I say to sit in first bench, right, they will scold me for this 4 years. After that 2 years, right, they will understand. So 6 years I should get scolding from them for no reason that I'm not doing it for my own advantage. Not getting. No. Joker gone. Not getting. No. Typing, no. Kamath scratching. Jyoti gone. This girl gone. No starting problem. Nimi gone. Ush. ಆಫ್ ಮಾಡ್ಬಿಡ್ತೇನೆ. ಗಾಟ್ ಇಟ್? ನೀನೇ ನೋಡು ನಮ್ಮ ಶಿಷ್ಯ ಅಂದ್ರೆ. Why you have to clear? ನೀನು ಅದು ಮುಂಚೆ ಕ್ಲಿಯರ್ ಮಾಡು. ಇದಕ್ಕಿಂತ ಮುಂಚೆನೆ ಕ್ಲಿಯರ್ ಮಾಡ್ಕೊಂಡ್ ಬಾ. ಲೂಪ್ ಒಳಗಡೆ ಅದು ಹಾಕ್ಬೇಡ. ಲೂಪ್ ಒಳಗಡೆ ಹಾಕಿದ್ರೆ ನೀನು ಅವನಿಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡು ಫಸ್ಟ್. ನಿಮ್ಮಿಬ್ಬರಿಗೂ ಅರ್ಥ ಆದ್ರೆ ದೆನ್ ಇಟ್ ಈಸ್ ಬೆಟರ್ ಟು ಡೀಲ್. No, gone. Harshit gone. Scratch pad. ಅವನಿಗೆ ಸ್ಟಾರ್ಟೇ ಆಗಿಲ್ಲ. ಬಾಲಾಜಿ ಸ್ಕ್ರಾಚ್ ಪ್ಯಾಡ್ ಸ್ಕ್ರಾಚಿಂಗ್. ನಿಂಗೆ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ ಏನಾಗ್ತದೆ ಅಂತಾನೆ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. ತುಂಬಾ ಸ್ಕ್ರಾಚ್ ಹಾಕಿ ಏನೋ ಸ್ಕ್ರಾಚ್ ಮಾಡ್ಕೋತೇವೆ ಇದೆಲ್ಲ. ಮಾಡು ಟ್ರೈ ಮಾಡು. ನೆಕ್ಸ್ಟ್ ಗಾನ್ ಟ್ರೈಯಿಂಗ್ ಆರ್ ಇಟ್ ಈಸ್ ಆಕ್ಟಿಂಗ್. ಕರೆಕ್ಟ್ ಲೈನಲ್ಲಿ ಇದೆ, ಕರೆಕ್ಟಾಗಿ ಕುಡಿಸ್ಬೇಕು ಅದನ್ನ. ಕರೆಕ್ಟಾಗಿ ಕೂತಿಲ್ಲ ಅದು. ಡೈಲಾಗ್ ಹಿಂದೆ ಮುಂದೆ ಆಗಿದೆ. ನಿಮ್ಮ ಡ್ರಾಮಾ ಡೈಲಾಗ್ ಹಿಂದೆ ಮುಂದೆ ವರ್ಕೌಟ್ ಆಗಲ್ಲ ಕಣ. ಲಾಜಿಕ್ ಸ್ಟೋರಿ ಹೇಳ್ಬೇಕು ನೀನು ನನಗೆ. ಸ್ಟೋರಿ ಇಸ್ ನಾಟ್ ಲಾಜಿಕಲ್ ನಾವು. ರೈಟ್. ಟ್ರೈಯಿಂಗ್. ಅಂಜನಾ ಬರ್ತಾ ಇಲ್ಲ ಗಾಡಿ. ಟ್ರೈಯಿಂಗ್ ಹಿಂಗ್. ನೆಕ್ಸ್ಟ್ ಮೇಲಿಡು ನೀನು. ಅಲ್ಲಾಗಿಟ್ಟಿದ್ಯಾ. ನಾಟ್ ಕಂಫರ್ಟಬಲ್ ಆನ್ ದ ಬೆಂಚ್. ಯುವರ್ ಚಾಯ್ಸ್. ನೋ, ಸಿಟ್ ದೇರ್, ಸಿಟ್ ವಿತ್ ಹರ್. ಯು ಶುಡ್ ನಾಟ್ ಸಿಟ್ ಅಲೋನ್. ಸಾಕಾಗಲ್ಲ ಅವಳಿಗೆ ಮುಂದೆ ಕುಡಿಸು. ನೀನು ಇಲ್ಲಿ ಬಾರೋ, ಒಬ್ಳೆ ಕುಡಿ ನೀನು ಆ ಕಡೆ ಸರಿ. ಅವಳಿಗೆ ಅಲ್ಲಿ ಕೊಡು ನೀನು. ಇಲ್ಲ ಅವಳ ಜೋಡಿ ಕೊಡು. ಶಿ ಕ್ಯಾನ್ ಆಲ್ಸೋ. ಮೇಡಮ್, ವೇರ್ ಇಸ್ ಯುವರ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್? ಆಡ್ ಸಿ ಯುವರ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್, ರೈಟ್? ನೋ. ಮೇಡಮ್, ರಿಮೂವ್ ಯುವರ್ ಹ್ಯಾಂಡ್. ನೋ ಆನ್ಸರ್. ಟ್ರೈಯಿಂಗ್. ಗುಡ್ ಟ್ರೈ. ರೈಟ್. ಟ್ರೈಯಿಂಗ್. ನೋ ಟ್ರೈಯಿಂಗ್. ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ ಏನ್ ಮಾಡ್ಬೇಕಂತಾನೆ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. ಕರೆಕ್ಟ್ ಕೃಷ್ಣ, ಕರೆಕ್ಟ್ ಇದೇನೋ? ಹೌದಾ? ಬರೇ ಇದಿಲ್ಲ. ಯಾರು ಬರ್ದಿಲ್ಲ ಪ್ರೋಗ್ರಾಮ್. ನೋಬಡಿ ಹ್ಯಾಸ್ ರಿಟನ್. ಸಮ್ ಹ್ಯಾವ್, ನೋ ಆಫ್ ದೆಮ್ ಹ್ಯಾವ್ ಟ್ರೈಡ್. ಅವ್ರಿಗೆ ಕರೆಕ್ಟಾಗಿ ಬಂದಿಲ್ಲ. ವೆರಿ ಗುಡ್. ನೋಡೋಣ, I'll discuss on that. Yes. Now what we do is, listen to me. Hello. Listen to me. Guys, stop whatever you are doing. Please concentrate on the board. This structure you understood? This structure you understood? Then what you have to do next? While writing a program, what is the first step? What is the first step in writing a program? Visualization. You should have a visualization how it will look. This visualization you should visualize, okay, this is how the memory is there. There is a value starts from the address 40 to 48, some values are stored. There are 5 values stored, and the higher byte is stored here, lower byte is stored here. If I put the maximum value, the answer will be 4FB. 4 is stored in higher bytes in this. This structure should come in front of your eyes, or you should get this idea as soon as you read the statements. Right? This is in corporate business, they will call it as a customer requirement analysis. You should understand a customer. What customer says is in English language. You know 8051. You should map his English language to your knowledge of 8051 and visualize it. Oh, if I do like this, then his problem might be solved. Is it clear? This is not simple job. This is not given for any freshers. This needs 10 years or minimum 7 years in the industry to visualize that level of requirement. Because what you visualize, on your visualization 2,000 to 5,000 people will work. If your visualization itself is wrong, 5,000 people work is wrong. You're understanding? So it is loss of such a huge business model. So this part is very, very important. Is it clear? Then what we are doing is simple visualization. Customer requirements will be more complex. This is a real-time application. Right. So after visualization, what is the second step? What is second step? Logical analysis. You have to do the logical analysis, that is like put a FF value and say like this is a one rough value you'll get. Next, what is the next step? Flow chart. What do you have to do first? First, what you do, tell me. Guys, are you clear? What is that I am discussing? Visualization is understanding the English sentence and see how this English sentence means in your architecture, 8051 programmer's model. What it means there. That mapping is called as visualization. Then logic, then do one analysis on that. What is the number if they say addition or multiplication or any other thing on the given number, you should take always the maximum number. If it is a division, take the lowest number also. Multiply the addition and the subtraction, you should take the subtraction and division, you should check with both highest number and lowest number. If it is addition and multiplication, highest number is enough. You understood what is this means? You check FF value with this. The maximum result what you get is this. It cannot be more than this, highly impossible. Right? Then what you have to do? Start the first step. What do you have to do? First step. Tell me quickly, what is the first step? Yeah, first step I have to move this R0, R3, clear this, right? Clear this, clear the R3 equal to 5, this R0 equal to this. R0 equal to 40, then R3 is 5, you know how to do it, correct? You know, move the R0 comma hash 40, that you have to do. Then what is that? R7 equal to R6 equal to 0, 0. And one more thing you have to do is CLRC, clear the carry. Though on reset, PSW by default value is 0, 0, clear the carry. These are safety instructions. So these are safety instructions. Even if you don't put this, nothing is wrong. But still we use some safety instructions to avoid unexpected problems. Clear? This is the first step. It is called initialization. We have initialized whatever we have visualized, we have initialized in program. What is the second step? Add. Thank you, add model. What we have to do is, first we have to put this value in A equal to at or not. Put that in the loop. We'll give the loop to 2. Okay. We'll see like whether the loop, where to give or this. We know now R0 is 40. At 40 we have some value. That we have brought it to A. That value, let us say it is FF only. Okay. Next what we have to do? Increment R0. Then it will point to 41. Next what I have to do? Add A comma at or not. If this instruction is there in your this one, check the instruction list. A comma at or not is there. At or not is there, then it is good. If it is not, no, will come. Is it clear? Is this clear? At or not is there for sure. Move A comma at or not. With add C it is there. The instruction itself is add C. Okay. Add also is there. That is what I am asking. This should define why we have to do add C. Then we should do that. Now I have just added it. I don't require a carry now because carry is clear. Is it clear? Is it still here? It is clear. I have added the content of 40 and 40H. I will get some result. FF plus FF. It is. What is the value? FF plus FF. 1 FE. Correct. 1 FE. If I add these two numbers, the result is 1 FE. That means here guys listen. When I say listen, please concentrate. Or when it is a new thing, it is your duty to concentrate fully. Okay? And let me also tell you, my duty is not to all of your understanding or not. My duty is to come here and give a lecture and go. I am not here to make you to come and sit in front bench. You should concentrate. You should come. It's not my duty. Is it clear? My duty is to come here, express whatever I know, then leave the class. It's not my duty. You should keep quiet. You should listen. You come to the front bench. You just do this. No. You guys are not kids. Please understand, I am not doing it for my duty only. I am just taking enough care only because I am emotional madness. Yeah. What we do here, add a comma at or not, what happens? If we do this, a equal to a plus at or not. That is, if it is ff plus ff, maximum possible number, then the answer is 1fe. What happens? Lower bytes are stored in A, this will be stored in carry. Very important statement. You should analyze this, what happens after this instruction. Now you will understand what you have to do in the next cycle. Right? Right, hold on. Add this to this. Done. Next, what I have to do? That is the final result we have to push. Guys, listen. What he is saying is like we have to push the higher bit to R7 and the lower bit to this thing. So in that condition,
it's like if there is a carry, then increment R7. After this, increment higher bit. If there is no carry, then don't increment.
You understood what is his point? This we have done it in some logic, right? Where we have done this? If there is a carry, the increment to R0, R1, we have done it somewhere. No. Huh? Normal addition, we have done this thing. Yeah. If we don't do that, there is no other way. No, what I am thinking is, guys, listen. What I am thinking is, whatever the value you increment it at or not, you push that to some register. The register might be R6 or something like that. So whenever you add a result, and store back the result in R6. So every time you add the R6 to the next value. When you add with C. Okay. What we do is like we have two different approaches now. One, whatever he is saying, like use R7 as a carry indicating register. Right? And then use one instruction here, jump on carry to increment R0. Increment R7. Right? We'll see both quickly. This is a general approach to write any program. Any program you want to write, initialize first, understand what you have to do step by step, then you write a whole program. If you practice 10 programs like this, then you don't need to do the logical analysis and all this visualization, initialization, nothing. You just visualization is required. You just need to visualize it, write a program directly. But till then, you should follow the procedure. Okay? Yeah, what he is saying is, if there is a carry generated here, jump on carry. Jump if no carry. To where? Like what we have to do? Jump on no carry to skip. In the skip. Acha, correct. Increment R7. If we get a carry, increment R7. If we don't get a carry, jump to this one. Right? Next. Next we have to write skip. R6 comma A is, this is stored in A, right? FE is stored in A. This we have to push it to R6 because we have agreed that R6 will hold the lower digit of the result. Lower result is stored in here. Right? Done? Next what happens? skip move R6 comma A, then DJ and Z R3 comma here. Where is here? Here is here 2. Correct? Is it clear? This is your program. Now we will analyze this program. Last step in the program is called a trace. Now you have to trace this logic and understand whether this logic is right or wrong. Why we should clear the carry every time? No, anyway it will not affect. We are not adding it here. Increment? Correct. Right. It's a good discussion. Right. This is what happens in first bench. Correct? No. For last bench, so many people are sitting in front of you. You will see like what is this fellow is doing, that fellow is doing. Right. Anyway, guys, I believe some of you will trace it back. We'll trace it back, including this statement. What is that? This CLRC will get inside. Where do we get inside? Before this or somewhere you have to CLRC.
Here should come at 2, that here should come at increment because it's again add 2 and 2. Because 2 is already added to 1.
Increment R0.
Here it should come here.
Then R0 value will go to A. A is what is the value? A already has FE. FE should it be added with this. So here we will give it to CLRC. Right. Now we'll try to understand this program. Whatever we have written rough, we'll try to understand. Please give a put your concentration here. We'll remove the CLRC from here. Right, done. So what is this we are doing? This you understood. This part you understood, initialization. After initialization, what we did? A equal to content of R0, that is FF, is moved to A. Then clear C, the carry. Then increment R0. R0 is incremented to 41. Add A comma at R0. That 41 content and A content is added. A content is 40's content. Then like 41 content, right now at R0 is pointing to 41. 41 content is FF. Both of them have added FF plus FF. The result is 1 FE. The FE will be stored in A, is stored in carry. So what we are doing now is instead of add C, using add C instruction, what we are doing is we are using one register called R7 to indicate the carry. This is called as carry indicating register. What we do with this, whenever there is a carry generated, we'll increment it by 1. Whenever there is a carry generated, how do we check that? This till here you understood? FF 1 FE, the result is stored in A and 1 is carry. Now we write jump on no carry to skip. If there is carry is not generated, then you have to go to the skip. That means you are not incrementing R7. Only and only when carry is generated, then it will come to this increment R7. In this case, carry is generated, R7 will become 1. Right? Then it will go to this statement where in which move R6 comma A. The A value, what is A value? FE will move to R6. Then like this statement you know, DJ and Z R3 comma here. What is R3 value? 5. 5 will become 4 now. Then like here is where clear C. We'll trace it one more time. Then we'll be very clear. CLRC. Then increment R0. Previously it was 41. Now it will point to 42. Now at this point it is 42 value. Now add A comma add R0. What is A value? FE. And then like at R0, 42 value, FF. So this addition is FE plus FF. What is the answer? 1FD. Are you sure? 1FD. So this is stored in A, this is stored in a carry. This one is stored in a carry. As it is carry is generated, again we are incrementing R7. Previously R7 was 1, now it is 2. Right? Next is move R6 comma A. Whatever the FD is there, like R6 will have FD now. DJ and Z, R3 was 4, now it will become 3. 3 is not 0 again because decrement, jump, non-zero. Till R3 becomes 0, it jumps back. Again jump back to CLRC. Clear it. Increment R0, 43. A value is FD now. FD is added with at R0. 43 content is for FF. Add it. FD plus FD, right? FD plus FF. What is the answer? FC. So A holds FC now. Carry is generated. So increment R0. This statement goes wrong. JNC is wrong. Jump on no carry. Carry is generated. So it will not execute. It will come here. Increment R7. Then move R6 comma A. R6 is A is what? FC. DJ and Z now it is 2. Then goes back here. Clear the carry again. Why this clear carry is required here? You understood. He gave you one good reason. What is the reason? If I don't clear the carry, what happens here? Previous carry will affect this one. If I don't clear carry, that is what his statement. That is what his statement, but it is wrong. Why it is wrong? Every time you do addition, the carry flag is updated by itself. Every time you do addition, carry flag will be updated by itself. Whether if the result of that addition is 0, then it is 0. Carry is becomes 0. The result of that addition is carry is generated 1, then it is 1. Every time you do it. So this addition carry is what we require here. So CLRC, even if we drop from here, nothing will happen. Is this clear? Is it clear? So it is not mandatory statement. Even if you remove, nothing will happen. Because this carry is generated every time when you add two numbers. So you can remove this statement. Removing one instruction is a huge gain. On what? On the memory size, on the timing. All engineering deals with only two things. What is that? Space and time. Okay? So one instruction removal will help me in saving the time because also the space. Right. Next it will go to increment R0. R0 is what? 43, 44. Then 44 content it will take, and in here that is FF. A content is FC. FC plus FF. What is the value? FB. A is FB and carry is generated. That carry is generated, that is why this will become 4. Move R6 comma A, this cycle will repeat. You understood this now? You understood this now, huh? Yes, yes. That is also very good. See, this is all loop numbers. Here R3 is 4 here only. Why is R3 4? You understood for it. In the first loop itself, we are adding two numbers. So we don't like finding the largest number. We need, if there are 5 elements, we need to put 5 here. But when it is addition of array, then we have to take it 4 because we are adding two numbers in the first cycle. Next cycle we will add one more number. Akshay. A80. No, I didn't get you. Repeat it. Right. What he is saying is, don't put this instruction. Which instruction? First instruction, A00. A0 you put. First you take that value from 40. That means this will remain standard. So it is an ideal condition. That is what is the point. Yes. You understood his point. Anyway, we are not using R6 in anywhere in the program. If I put it here, what is the advantage?